Good afternoon, everyone. My name is Duncan, and today I will be presenting my research on the effect of inhibition of HSP90 on malignant phenotypes. This research was conducted through the West Virginia Inbre program alongside Marshall University's School of Medicine. The reason why I conducted this research is because in the past 2 years, I've had 3 family members diagnosed with various forms of cancer. As I was conducting this research, I got a phone call from my mom telling me that a family member currently has lung cancer, which is what my project is investigating. With that being said, lung cancer is the most commonly diagnosed cancer and is the leading cause of cancer mortality seen in both men and in women. There are 2 common causes of mortality associated with the treatment of cancer, and those are metastasis and drug resistance. In terms of this presentation, I'll be focusing on my metastasis investigation. So phenotypes that are expressed is what commonly kills patients. It should be noted that these phenotypes may not be initially present or may become present to adapt and survive the treatment. It is our objective to use HSP90 inhibitors as an adjuvant therapy for a broad range of cancers. By doing so, it is our hope to increase the efficacy of the mainline treatments by prevention of adaptations of the cancer. This is a brief outline of what this presentation will be going through. This leads me to my first part of my investigation, which is EMT. And what EMT is an epithelial cell's transition to a mesenchymal state. So on the left here is a depiction of an epithelial cell, which is good. This is what we want. These are normal cells. On the right side is our mesenchymal state cell, which are bad. We don't want those. So how my research was able to track this transition was through these tight junctions called E-cadherin depicted through the epithelial cell. And essentially what E-cadherin does is it holds the epithelial cells together. So when the epithelial cells begin to lose the E-cadherin and these tight junctions, the cell becomes more motile. And this is what transitions it into a mesenchymal, one of the things that transitions it to a mesenchymal state. And when it becomes in a mesenchymal state, this is when it starts to develop the properties to metastasize. And what we see with lung cancer is that the cells will metastasize into regions of the brain and into the lymph nodes. I know you're probably wondering, what in the world is this HSP90 thing this kid is talking about? So I wanted to highlight 2 key bullet points here. Inhibitors such as AUI-922 are available, which is what my project utilized for my investigation, and the expression is upregulated in many cancers. This leads me to my hypothesis, which states HSP90 inhibition will prevent the acquisition of the malignant phenotypes of drug resistance and mesenchymal state in A549 lung cancer cells. This was the experimental protocol that I used, and it was a 4-day experiment that I conducted extensively over the summer I worked on this. So our first 6-well plate was our control plate. The top 3 wells were a vehicle. We didn't expose the cells with anything, just regular cells that did have lung cancer. The bottom 3 wells were lung cancer cells exposed with AUI-922, which is that HSP90 inhibitor. Our second 6-well plate was treated with 10 nanograms per milliliter of TGF-beta, and what TGF-beta does is it induces EMT, so we'd expect the cells to be in a more mesenchymal state. So our top 3 wells were cells that were exposed with the TGF-beta, and then our bottom 3 wells were cells that were exposed with the AUI-922 and TGF-beta. Experimental endpoints here. Flow cytometry is our primary endpoint measurement, and what that does is essentially allows us to look at characteristics of the cells. We use the antigen E-cadherin, which labels epithelial cells transition from an epithelial to a mesenchymal state. These are the results that I got. When looking at the control group and cells that exposed with AUI-922, we did see a more pronounced effect with E-cadherin, and you can see that with the 74.5% to the 49.64%, which essentially means that cells that were exposed with AUI-922 are keeping a more epithelial state or reverting to an epithelial state. In comparison, we see that the cells that were exposed with AUI-922 also were in a more epithelial state as well. A bar graph representation of my results. We had an N value of 3 to 6 for each experimental group, and then we had a p-value of less than 0.05. My conclusions state that AUI-922 treatment caused cells to retain a more epithelial state even upon induction by TGF-beta as measured by E-cadherin expression. These results support the possible use of HSP90 inhibitors as adjuvant therapies to increase the efficacy of mainline chemotherapies. I have a lot more research that I would love to show you guys, but based on time frame, this is all that I can show you at this time. This time I'd like to thank Dr. Vincent Solers and Nick Bacon. And I also like to thank the West Virginia Inbre program and the National Institute of Health for funding this research to allow me to investigate something that hits very close to home to me. Thank you guys.